All right, I think we're on. It's 10 o'clock in the morning here on the East Coast. So good morning, good afternoon, good evening, everybody, wherever you are in the globe. Welcome to the second day of our in Pharma conference. We had a great day yesterday, and today looks as exciting. I'm Volya Chaputin, and I'll be your moderator for the first half of the day. And we do have a really great agenda for today. So stick with us for the next 2 hours. Before I jump into the program and introduce our first speaker, just a few housekeeping items. So we do have chat going on. So if you have a question during the presentation, please post that question in the chat window, and then I'll communicate it to the presenter. And all other questions that are not going to be answered will be moved to our Slack channel. And I think Harvey will post a link for the Slack channel soon. So without further ado, I'd like to introduce our first speaker, who is Timothy Tsai from Harvard University, who will have the opening remarks. So Timothy, take it away.
Thank you, Vola. Let me go ahead and share my screen. Good morning, R in Pharma. Welcome to day 2 of the R Pharma 2020 conference. I hope that you've been enjoying the proceedings so far. I know I've learned a lot and have been watching the presentations with a lot of interest. Particularly, I wanted to call out Bo Wang's presentation on metaprogramming Shiny apps, making Shiny apps. That was an enlightening presentation. When I thought about it, I was actually a little concerned because I was like, wait, my job, I make Shiny apps. Is this going to replace me? So I stayed up all night thinking about it. And, I came to the conclusion that until you make a Shiny app that can copy and paste from Stack Overflow, I should be fine. I have no relevant disclosures. As I said, my name is Tim. I'm a member of the Marcus Institute for Aging Research, which is a Harvard Medical School research affiliate housed within a greater Boston area senior care organization. We have over 24 scientists working across different areas of aging research, including the aging brain, mobility and falls, and musculoskeletal research. They're doing work in a diverse portfolio of research areas and methods, which I'm not going to read, but include gait, body composition, biomarkers, genetic epidemiology, and really doing cutting edge research. Within the Marcus Institute, I'm a member of the Biostatistics and Data Sciences Center. Our primary responsibility is to develop and deploy software solutions to help our researchers answer their scientific questions about the illnesses and mechanisms of aging. And we do this by creating scalable software tools and workflows to help accelerate their work, while also improving rigor and reproducibility. And I will demonstrate how we've accomplished this using R and associated platforms like RStudio Connect and RStudio Server, using some examples from our work. First example comes from the Framingham Osteoporosis Study, an ancillary study of the Framingham Heart Study. The challenge that we had in this study was to identify a subset of study participants for biomarker sampling, conditional on the availability of data from a range of siloed data sources. So not only the clinical questionnaires, but also imaging that doesn't always talk nicely with other systems. To do this, we built a study dashboard for cleaning of data, operational reporting of the number of participants over time, and specifically for the biomarker sampling, we developed a module that identifies the suitability of given participants given the availability of data, which you can see here. And this work is possible through the versatility of R to connect to different data sources, as well as the robust capabilities of data visualization packages to present this data in real time for study teams to rapidly assess which participants would be suitable for sampling and and for further study. Our second example comes from a smartphone, a study of mobility and falls using smartphone data. In this study, we captured motion sensor data from smartphones to look at how certain illnesses of aging affect the patterns of gait and sway in older adults. And the difficulty here is that the time series data provided by the accelerometers and gyroscopes not readily visualized. You can't exactly open it in an Excel spreadsheet and know what's going on. They also require some processing in order to rotate the axis of the sensor data to a common orientation. So with one of my colleagues, built a application that not only does the pre-processing, but also can visualize this data in 3D, as well as providing an interface for quality control. And here we have an example of the 3D, of the sensor data in 3D, and a panel from our cleaning application, which displays the sensor data, allows research assistants to mark certain segments for either further inspection or removal, and uses the robust visualization capabilities of packages like Plotly to display the data in multiple dimensions. We also work in pragmatic and clinical trials. This example comes from a trial called TRAIN-AD, which was a cluster randomized trial to reduce inappropriate antimicrobial usage in nursing homes. In this study, we use an algorithm to, we abstracted medical record data and then applied an algorithm to determine whether nurses and MDs were prescribing antibiotics appropriately in a potential lower respiratory tract or UTI infection. And we also had a need to facilitate the export of processed data for the study teams to be able to, do their own summaries. To accomplish this, we used several off-the-shelf packages to yet again build a shiny dashboard that provides a dynamic flow diagram summarizing. This diagram summarizes adherence to the intervention, which was a feedback report of the provider's prescription patterns. This is still in analysis, so cannot necessarily show the numbers, but this diagram was a vast improvement over the hand-drawn reporting or handmade reporting in the past. We also created an export tool that applies the algorithm that I mentioned and makes it readily exportable for research assistants and the study teams. Now, so one of the themes of what I've been talking about, you probably saw a lot of packages that you know of. And collaboration and community development is in the DNA of R. Our work is vastly accelerated and improved by the use of these community-built packages. And that's one of the major strengths of working with R. And sort of beyond that, when Phil asked me to give remarks at this conference, I was sort of like, well, we're not exactly in the pharma space. And I didn't really get it until I thought about it more. And I think that the opportunities like this to see what people are doing in other spaces is how tools are built, how people learn about what are the needs of the community. And talking about the future, in the pharma community, a lot of this may be already reality, but we sort of envision a harmonized architecture for study conduct that starts with data standards and feeds into a study design app that reads in a SAP as a piece of data and can build project bundles that are totally harmonized, which will facilitate the in combination with modular study applications using output templates, can facilitate the automated creation of reports and analyses, as well as building towards study metadata that can be harnessed for improved dissemination, not only of data for meta-analyses, but potentially synthetic external controls for synthetic trials, and also making available models through APIs after you train your machine learning model based on this data. Imagine being able to just ping an API as a collaborator instead of having to copy a bunch of code and wonder which packages were used. And this is all made available through R. Obviously R may not be the perfect tool for some of these elements, but the publication of documents through RStudio Connect, the powerful capabilities of R Markdown, and of course R Shiny make it really easy to not only read in various types of data, but to provide output. And I think that I'm very grateful for our organizing committee for inviting us, and I hope that you'll go into day 2 with sort of a sense that we're all part of a community building a lot of tools together, and that we have a lot to learn from each other. And this constellation of great art, of great packages and great people makes R a well-suited tool to tackling diverse challenges, not only in aging research as we've done, but also in the pharma space. So thank you very much. And just a brief plug for our website, which is called Curator. And really appreciate your time. And I hope you enjoy the rest of the day. Thank you.
Thank you so much, Timothy. So I've collected some questions, and since we don't have time to answer them live, I'll just post them in the Slack channel. So if you could just come out and try to answer, that would be great. So thank you.